It is almost impossible to think of Saturn without picturing its signature rings. But new research suggests the clumps of rock and ice that make up the rings we consider almost synonymous with the planet now actually started out life as different planets altogether. The study suggests the rings of Saturn, along with those surrounding Neptune and Uranus, are made up of pieces of Pluto-like dwarf planets that strayed too close to the giant worlds long ago. Researchers at Kobe University, Japan, presented a new model for the origin of Saturn's rings based on results of computer simulations. Their study, published in the journal Icarus, also addressed differences between the composition of the rings of Saturn and Uranus. The origin of rings around giant planets remains elusive, Ryoki Hyoto and co-authors wrote in the paper. Saturn's rings are massive and made of 90 to 95% of water ice. In contrast, the much less massive rings of Uranus and Neptune are dark and likely to have higher rock fraction. Just after the solar system formed, thousands of dwarf planets the size of Pluto once orbited in the Kuiper Belt. The Kuiper Belt is an icy region of the solar system, far away from the Sun in the space beyond Neptune, where Pluto is found. But 4 billion years ago this changed, in a period known as the Late Heavy Bombardment, when the giant planets underwent orbital migration. In the new study, the researchers simulated this migration to work out the probability of planets like Jupiter, Saturn, Uranus and Neptune colliding with the dwarf planets in the Kuiper Belt. Results showed that Saturn, Uranus and Neptune experienced close encounters with the large objects multiple times, according to the so-called NICE model. At the time of the Late Heavy Bombardment, giant planets could have experienced a significant number of close encounters with bodies scattered from the primordial Kuiper Belt, the authors said. The new study simulated the migration and found in many cases fragments comprising 0.1-10% of the initial mass of the passing objects were captured into orbits around the planet. Fragments with an initial size of several kilometers are expected to undergo high-speed collisions repeatedly and are gradually shattered into small pieces. These collisions between fragments are also expected to circularize their orbits and lead to the formation of the rings observed today. The findings show the rings of giant planets are natural byproducts of the formation process of the planets in our solar system. This implies giant planets discovered around other stars, like some recently, are likely to have rings formed by a similar process. The authors hope further discoveries of rings and satellites around exoplanets will advance our understanding of their origin.